Okay, we're looking for the equation when y is directly proportional to x with a constant of proportionality equal to 3. What'd you come up with, Anna Marie?
Y equals 3x.
Yeah, all of that is just saying y equals 3x. Okay, remember our basic idea for directly proportional. Try and get that little thing off the bottom there. There we go. Was that y equals kx. That was kind of the definition or the formula for directly proportional, is that we had this constant of proportionality, showing how one variable is related to the other. Remember, we called this the independent variable, how it's related to the dependent variable. Okay? Yeah, Anna Marie?
Why do you use k?
For constant of proportionality. Yeah, which starts with C. They just do. I think, I don't know why they don't use C. Maybe you don't confuse it with an O or something. I don't know. That's just what they do. And you know what? In different math books, you may see it differently. Okay. We know that K is, in this case, K is the same thing as what? It is a coefficient. But what did we say this was the same as? Yeah, it's really the same as the slope for a line. The unique thing about directly proportional things is that these lines always go through the origin. They always have a y-intercept as well. So you're not going to see the plus b at the end. Okay. All right, so all of this just says this. Okay. What if I gave you an equation? See if you could write the sentence for it. All right. Suppose I told you that y equaled 2/3 x. All right. Could someone describe what's going on there? Give me a sentence kind of similar to the first one. Madeline?
Y is directly proportional to x with a constant of proportionality equal to 2/3.
Okay. Y is directly proportional to x with a constant of proportionality equal to 2/3. Okay? Good. Good. So, there's not a whole lot of, you can't really get it all that tricky with these. Okay? Nor are we trying to be tricky with these. It's just trying to show how these variables are related. Okay? Again, direct proportion. What did we say the opposite of directly proportional is?
Let's have an error for a second. Sorry.
What's the opposite of directly proportional? What? It's not indirectly, it's in... Come on, if you don't know, think or look. Don't doodle and wait for someone else to do your thinking for you. Come on. Grab your book if you need to. What's the opposite of directly proportional? We're in section 8.8 here, I'm sorry, 8.9 with directly proportional. The chances are it's somewhere around there. It's not indirectly. Do you have it in your notes? If not, you should have your book out. Come on. What? Inversely proportional. Okay? We have directly proportional and inversely proportional. It's in the next section after directly proportional, or direct variation. All right? In section 810. What's the real difference here? What's happening with directly proportional variables? Variables that are directly proportional. It all has to do with what happens to y as x is changing. What's happening?
Like, if it's, you have a higher number, then x would be, then that number times x would be higher than what it would be if it was negative.
Kinda. Madeline?
Well, basically, when x changes, y changes in the same direction based on the constant proportionality.
Okay. Y is going to change based on the constant proportionality. We're changing kind of in the same direction. Okay. Directly proportional. The idea is when x is increasing in magnitude that y will as well. Okay. Alright, so if x is getting bigger and bigger, y should be getting bigger and bigger. And again, we're talking about magnitude. It is possible to have negatives, okay? But the idea here is the magnitude, or the absolute value, is going to get bigger and bigger, okay? Now, that's kind of the opposite of inversely proportional, where as x gets bigger and bigger, y is going to get smaller and smaller, okay? Or, in other words, it's going to get closer to 0, okay? And we'll work on some of that. We'll look at inversely proportional stuff tomorrow, okay? Now, I want to run through a couple of these here with you. If you're near page 393, so go ahead and, if you're not on that exact page, turn to page 393. Now, I want you to just run through real quickly page 393. Look at the bottom of the page. You have a number of different statements, and here you're given a certain value. In other words, you're kind of given a point. So for instance, number 1 says y varies directly as x, and y equals 9 when x equals 54. They're asking you to find the constant of proportionality. All right. Now, how do we find the constant of proportionality again? We know it's directly proportional. Anna Marie? Y equals kx, all right. Well, if we don't know the equation, they didn't tell us. Jacob? Take 54 and divide it by 9. What do you guys think? Fun. Looking for some feedback. Okay? Unless you're thinking nothing, in which case you need to think something. Alright? Come on. Jacob's saying take 54 over 9. And that would make your constant proportionality be 6. You're saying take 9 over 54. So our constant of proportionality would be 1/6. What do you think, Kaya? What? 9/54, okay? Alright, we're going to take y over x. Or in other words, the dependent variable over the independent variable, okay? The x is that independent variable, the thing that's going to be changing. Y is going to be the one that is dependent on the value of x. Alright, so in this case, your constant of variation would be 1/6. Now, apply that same idea here to number 3. T varies directly as s. Uh-oh, we don't have y's and x's anymore. Which one is the y, or the dependent variable here? Sam? T. What you said? Okay. T. T is the one that is varying, right? Just like in the previous one, y was what was varying. Okay? And it was varying as s changes, right? That's what that's saying. Okay? So t varies directly as s, and then we're given that information. So t is our dependent variable, and it says t equals -16 when s equals 2. Right? So what's our constant of proportionality here? Elizabeth? 8. Okay? -16/8. Does anyone have any questions about that one particularly? Sam?
Right, wouldn't it be s over?
Well, it's dependent value over independent value, right? And we just said that t is the dependent, right? So you put the t value -16 over the independent value -2. Okay? So in this case it would be 8. Does that make sense? That's why it's kind of important to look at that initial statement. What is the one that's varying? That's going to be your dependent. Okay? And it's as the independent variable changes. Okay? Alright. Try the last 3 there. 4, 5, and 6. H varies directly as m. W is directly proportional to m. P is directly proportional to t. So, number 4. Everyone's finished here. What's our dependent variable? H. So our independent variable would be M. So that means our constant is what? Elizabeth?
-7.
Okay, -7. 112 over -16 would be -7. Okay? Good. Good. Does anyone have a question about that? Got it? Okay. How about number 5? W is directly proportional to M. What's our dependent variable? Jacob? W, okay? W is directly proportional to the independent independent variable M. So what is K?
25.
What?
25.
24?
No, 25.
25. Okay. 150 divided by 6 equals 25. Okay? Good. Are there any questions on 5? Yes, Eric? Wait, you had the hiccups? Yeah, go ahead. Alright, number 6. P is directly proportional to T. Okay? And P equals 210 when T equals 14. Okay? So, let's see here. Hey Bob, what is the dependent variable?
It looks like P.
That's right. P would be our dependent variable. T is the independent. And you have a value for K for the constant?
Um, 15.
15. That's good. Okay? Good. Yeah, we're doing 210 divided by 14. And we get 15. Okay? So, does this make sense? Again, make sure you identify what that dependent variable is and what the independent variable is. That'll help you writing your equations. It'll also help you finding this constant. Okay? That'll really help. Okay? Now, we're going to be doing ones that aren't necessarily just x's and y's and whatever. We're going to do some that actually have some realistic applications here. Okay? So, I'm going to give you guys some time to work together a little bit on the board and then finish up for homework. But, problems. Page... Okay. I'd like you to do page 393, or actually I guess it's starting on page 394, written exercises. And I'm going to have you do, I'm going to have you do 9 and 10, because 9 and 10 kind of take what we just did and take it one step further, alright? And then I'm going to have you do 17 to 22. Okay? There's some word problems here. And make sure that you draw a picture if need be. Write an equation, figure out, find your constant, and so forth. Alright, but especially on the word problems, make sure you identify which variable's which. It's real easy to get these backwards. Okay? So, I'm going to have you get started on those. And check your answers. Evens are not in your book, so I should see people coming up and checking answers, right?
So fine.
So finally it's fine. Oh yeah.
So 425.
You did that before.
H equals 425 and 8 equals 6. So when 8 equals that, what would it be? 420. 425.